You've probably been there. You ask an AI to edit a picture, something simple, and it gives you back something totally weird, right? I mean, these tools feel like magic, letting us conjure up incredible images with just a few words. But what is actually going on inside that AI's digital brain when it tries to follow our commands? Well, let's peel back the curtain and take a look. You type in a simple request like, make it sunny, and suddenly your photo has a banana where the car used to be. It's hilarious for sure, but it actually points to a much bigger question. How in the world does an AI interpret our language? And why does it sometimes get things so spectacularly wrong? Well, this gets at what researchers call the black box problem. We feed a prompt into the AI on one side, and we get a new image out the other side. But that whole process in the middle, the how, is completely hidden from view. We can't see its logic, which makes it really, really hard to trust or fix these systems when they go off the rails. And let's be clear, this goes way beyond just making bizarre pictures for fun. Once we start using these AI models in really high-stakes situations, that black box suddenly becomes a major, major problem. Think about it. Researchers from the University of Hull put it perfectly. In something like autonomous driving, a decision the AI makes based on what it sees could be a matter of life and death. If a self-driving car misinterprets something, we absolutely need to know why. Trusting these systems is impossible if we can't look under the hood. So how do we finally get a peek inside that box? Well, a brand new research paper introduces a framework designed to do exactly that. It's called SMILE. And yeah, it gives us a reason to do just that. Now that's a mouthful, but what's really cool about SMILE is that you can use it on pretty much any image editing AI. What it does is it looks at your text prompt and then creates a really simple visual heat map that shows you exactly which words had the biggest impact on the final picture. So in a way, SMILE lets us create a map of the AI's decision-making process. It's like we finally get to see how the AI connects the words we type to the pixels it ends up changing on the screen. And this right here gives you a fascinating look at how an AI's mind is actually organized. This plot shows that the AI naturally groups similar ideas together. See how all the sunny edits are clustered in one little neighborhood and the snowy ones are in another? This is the AI's internal concept map, and SMILE is the tool that helps us read it. So how does SMI actually build this map? The process is really clever, and it all boils down to some smart, automated experiments. Let's walk through how it works. Okay, so first you start with an image and your command, something like transform the weather to make it snowing. Then SMI just starts messing with that prompt. It creates dozens of variations by removing a word here, a word there, so you get prompts like transform weather, snowing, or just make it snowing. Then it tells the AI to generate a picture for every single one of those versions. And here's what you get. Check this out. The scene really only turns snowy when the word snowing is in the prompt. Take that word out and nothing. The AI is lost. This is the exact kind of clue that SMILE is designed to find. So in the next phase, SMILE gets analytical. It uses another powerful AI, a helper AI, to look at all those generated images. It measures exactly how different each one is from that original snowy picture. After that, a pretty straightforward statistical model crunches all the numbers to figure out which words consistently caused the biggest changes. And here it is. This is the payoff. A beautiful, easy-to-read heat map. The color tells the whole story. The hotter the color, so the more it goes from blue towards red, the more influence that word had. And you can see it plain as day. Snowing and sunny are glowing red. They're the words that are really driving the change. Now, this all looks fantastic, but here's the billion-dollar question. Does it actually work? I mean, how do you even check if an explanation is a good explanation? Let's take a look at the results. Okay, so to test this whole thing, the researchers took a normal street scene like this one on the left. Then they gave the AI the prompt, transform the weather to make it snowy, and got the image on the right. Now the question is, can SMILE correctly explain how we got from A to B? To see if SMILE was up to snuff, the researchers basically asked 4 key questions. First, accuracy. Does it actually pick the right words? Second, stability. If you change the prompt just a tiny bit, does the explanation go haywire? Because it shouldn't. Third, consistency. Do you get the same heat map every time you run it? And finally, fidelity. How much does this simple, pretty map actually reflect what's happening inside that complex black box? So let's talk accuracy. This chart is just fantastic. It shows the influence of each word from our snowy prompt, but this time it was tested on 10 totally different pictures. And look at that. The word snowing consistently every single time has the highest influence. It's not even close. This is crystal clear proof that Smile is nailing it. What's also cool is that they used Smile to test different AI models against each other. And the results showed that some models, like Instruct Pix to Pix, were really easy to explain. They got high scores for accuracy and fidelity. But others, not so much. This means Smile isn't just for understanding one AI. It's a powerful yardstick for comparing them and figuring out which ones are the most transparent. Okay, so we've mapped the AI's mind, we've tested the map, and it seems to work. But let's zoom out. What's the big picture here? Why does any of this really matter? Well, it all comes back to two words: trust and control. The researchers who created Smile said it best themselves. Tools like this are what allow us to actually build trust in these systems. When we can understand how an AI is thinking, we can finally get a handle on controlling its behavior. At the end of the day, cracking open that black box isn't just some cool science experiment. It's about making these incredible AI tools safer, more reliable, and most importantly, more aligned with what we humans actually want them to do. It's how we go from an AI that's just powerful to an AI that's genuinely trustworthy. This research really opens up a brand new chapter. We're just starting to figure out how to have a real conversation with these complex systems, which leaves us with one last big question. Now that we finally have a map to the mind of an AI, what should we ask it next?